Welcome to this lesson. In this lesson, we'll be discussing function types in Solidity. So what are function types in Solidity? Function types are the types of functions, simply put. So there are four types of functions in Solidity. We have the internal, which is default type. They can only be called inside the current smart contract. We have the external. They can be called from other contracts and via a transaction. We have the privates. They are only visible for smart contracts. They are defined in and not derived smart contracts. So the difference between internal and external is for internal functions, they can be called by derived contracts. For private, it can only be called by the contract that was defined. It cannot be called by the derived contract. And finally, we have the public functions. So the public functions are part of the contract interface and can be either called internally or external or via messages. For public state variables, an automatically getter of function is set. So what this means is, for public function, they can be called internally or externally by using this dots function. And for public variables, public state variable, if you have a public state variable, unsigned integer number equals 8, it can be called as a public function like this number. So a public unsigned integer, it can be called just like this. So function definition looks something like this. What we have function, the name of the function, followed, and then parameter types inside here, followed by the type, if it's internal, if it's external, if it's public or private, and followed by the return type. Now, what I mean here is a function can either be pure, view, or payable. If a function is pure, it means it doesn't read or write to the state. If a function is view, if it's marked as view, it means it only reads from the state. If a function is payable, it means that the function can receive ether, and then followed by the return types, what it should return. So let's see an example below. So this is a private function, marked as private, but you can call a public function. And this is an internal function, which can be called by derived contracts and from these contracts. And it's calling the same public function as this public function. And this is our public function here, marked as public. And we can also define an external function like this too. External, call it external. So function return types are now affect state. We have a function here called calculate area, as you can see. This is a function name. This is the parameter types. It takes unsigned integer 8 for length, unsigned integer 8 for breadth. And the visibility is public. And it's pure. When it marks by the keyword pure, we said it means it doesn't read from state or write from state. So all it just shows is returns length times breadth. And we've defined the return type here. So now something is worth of note. If we pass unsigned integer 8, let's assume we'll pass, for the first argument, we'll pass, remember the highest size for unsigned integer 8 is 255, right? So we'll pass 255 as the first argument and 255 as the second argument. The return type will not be unsigned integer 8 because it will be more than the size of unsigned integer 8 to be unsigned integer 16. Even higher than that. So if you do 255 and 255, it will revert. This won't work. But if you pass something such as 8 and 6, 6 times 6, will still be under unsigned 255. So this is marked as view because it reads from state. We have state variable L, we have state variable B. And this reads from state. It returns L times breadth. It reads from state, but it doesn't manipulate, it doesn't edit the state, so it's marked as view. So finally, this function writes to state, so it's only marked as public, not view, because it writes to state. So length equals length and breadth equals breadth. What is being passed? We are still going to practically run this on our MS editor. So a function can also return multiple values, such as this. So gets length and breadth, public view, reads from state, so in bracket like this, length times breadth. You can also pass the return of a function that returns multiple value. You can also assign it. It's called destructing arguments. If you're a JavaScript programmer, you would be used to this term, destructive argument. So you'd see what we do here is we calculate area, public returns, and then we call getLB, which returns length and breadth, and it's going to assign to this variable length and breadth, and then returns length times breadth. Also, a function can take an array as an argument. When this is the case, we'd have to temporarily copy the array to memory. Then after this function has been executed, it's going to be discarded. Later on, you'll get to see that there are three different memories, three different places that the Ethereum virtual machine stores data: memory, state, and call data. We can also use array as an output. And as I mentioned earlier, prior to Solidity version 0.8, we could not easily pass struct or return struct from a function. But we can also do that. You can pass struct as an argument to a function, and you can return struct as an argument from a function. This is something that will come in handy when you are signing, when you are performing signing in Ethereum using EIP 712. So as you can see, we pass struct to struct inputs. We can pass array of structs and the struct outputs by returning transfer props, and we can do transfers. So enough of talking, let us copy this into the MS editor and try it out. So let's create a new file, call it function types. Function types. Let's paste this here. Let's try to compile it first, see if there's any error. Okay, what error do we have here? Expected but got equal. So this is not supposed to be here. I like the way it's throwing the error while we are testing out, so it's easy for us to put debug, and it's going to help you learn well. So it says this declaration shadow an existing declaration. Transfers shadow an existing declaration. That means we already have transfer defined somewhere on this smart contract. So here we have transfers here. So this should be underscore transfers. Immediate transfers dot length. Transfer push this to this. Here undeclared identifier. Okay, this is undeclared. So let's have this here. Okay, unsigned integer hits. Unsigned integer hits. I didn't look at that error, but I figured that would be the problem. Okay, where else do we have problem? Data location must be memory. Or call data for return parameter in function. Oh yes, transfer. It must be copied to memory before it can be manipulated. Yes, this must be copied to memory. Different number of arguments in return statement. Different number of arguments in return statements than in return declaration. So it says return transfer, type of transfer. Let's see. Alright. When return transfers to pop, it pops one out and returns the rest in the array. So this will be returning, our return type here is supposed to be struct, just one, but this will be returning a lot. So in this case, we just want to return one. So this should work. Alright. State mutability can be restricted to pure. So in this case, it wants that instead of using view, we should use pure because we are not reading from state or writing to state. So compile. What I want is giving us. Okay, because this is now note this. Although we called get LB here, get LB in itself does not read or manipulate the state. It's marked as pure. So this is also going to be marked as pure because it also does not read or write to the state. So compile. Until we have an error. Function state mutability can be restricted to view because it reads from the state. Like I said, this course is going to be very practical and hands-on. That's why before now, I wrote a lot of all these smart contracts and did not test them. So we can test them out, look how these things together, and get to learn. So it says function state mutability can be restricted to view. So view, compile. Now everything works just fine. So I hope you've been able to understand function types in Solidity. See you in the next lesson.